Hey there, science fans. Today we're diving into the fascinating world of RTDs, resistance temperature detectors. These little gadgets are like the superheroes of temperature measurement, known for their accuracy and dependability. RTDs are used in a ton of applications, from keeping tabs on engine temperatures in cars to monitoring the heat in industrial ovens. In this essay, we'll unravel the secrets of RTDs, exploring how they're built, how they work their magic, and the different types you might encounter. So buckle up and let's get started. Let's get up close and personal with an RTD. At its core, an RTD is surprisingly simple. Imagine a thin wire, often made of a metal like platinum. This wire is incredibly sensitive to temperature changes. To protect this delicate wire, it's carefully wound around a core, often made of ceramic or glass. This whole assembly is then tucked inside a protective casing, kind of like a tiny suit of armor. This casing shields the wire from harsh environments and ensures accurate temperature readings. Think of it like a detective protecting valuable evidence. Now for the really cool part, how RTDs actually work. Remember that sensitive wire we talked about? Well, here's the secret. As the temperature around the wire changes, so does its electrical resistance. It's like magic, but it's really just science. When the temperature goes up, the wire's resistance increases. When the temperature goes down, the resistance decreases. This relationship is predictable and can be expressed by a simple equation. R equals sign R underscore 0, 1 plus alpha T. Don't worry, it's not as complicated as it looks. In this equation, R is the resistance at the current temperature. R underscore 0 is the resistance at a reference temperature. Alpha is a constant that depends on the wire material, and T is the temperature difference. This equation helps us translate changes in resistance into accurate temperature readings. Section 4, RTD families exploring the varieties. Just like there are different types of cars for different needs, there are different types of RTDs, each with its own strengths. Let's meet two of the most common types, wire wound RTDs and thin film RTDs. Wire wound RTDs are like the sturdy workhorses of the RTD world. They are known for their high accuracy and stability over time. These RTDs have a wire carefully wound around a core, usually made of ceramic. On the other hand, we have thin film RTDs. These are like the sleek sports cars of the RTD family. They are smaller and respond to temperature changes faster than their wire-wound cousins. In these RTDs, a thin layer of metal film is deposited onto a ceramic substrate. Section 5, RTD Scorecard. Weighing the pros and cons. Like any good superhero, RTDs have their strengths and weaknesses. Let's weigh the pros and cons. On the plus side, RTDs are incredibly accurate. They provide precise temperature readings, which is super important in many applications. RTDs are also very stable over time, meaning their readings remain reliable even after a lot of use. Plus, they offer excellent linearity. This means the relationship between temperature and resistance is nice and predictable, making it easy to get accurate readings. However, no superhero is perfect. RTDs can be a bit more expensive than other temperature sensors. They are also a bit fragile and need to be handled with care. Lastly, they have a limited temperature range compared to some other sensors. Section 6, wrapping up. Your RTD journey begins. And there you have it, a whirlwind tour of the world of RTDs. We've learned about their simple yet ingenious construction, how their resistance changes with temperature, and the different types that exist. We've also uncovered the superpowers of RTDs, their accuracy, stability, and linearity, as well as their few weaknesses. RTDs are essential tools in a wide range of fields. Keep exploring, and who knows what amazing applications you'll discover for these temperature sensing marvels.